Welcome back to the chemistry session. Today we are going to discuss about chemical energetics. First of all, we will check what is hydrocarbons. Hydrocarbons are those compounds which contain carbon and hydrogen only. Compounds containing carbon and hydrogen only, and this carbon and hydrogen covalently bonded together. That is hydrocarbons. As we know, with different kinds of transportation, mode of transport. The one is road transport. Most of the vehicles that use liquids obtained from crude oil as fuel. Now we will check what is crude oil. Crude oil is a complex mixture of compounds, that is hydrocarbons. This crude oil, it is a mixture of hydrocarbons. It can be separated into different components or different fractions based on their boiling point. This is possible by using a technique. That technique is fractional distillation. In fractional distillating column, we use this crude oil and it is heated to about 400 degrees Celsius to vaporize all fractions. Now you can see this is an oil refinery image. This crude oil is not very useful to us until it has been processed. So we want to separate the components based on their boiling point. This is carried out at an oil refinery. The given image is an oil refinery. Now we will check what is refining. Refining is the process in which crude oil can be separated into different fractions based on their boiling point. That means based on the boiling point we can separate crude oil into different fractions. Refining involves separating crude oil into various batches or fractions. For this purpose, chemists use one technique. That technique is called fractional distillation. Fractional distillation is used to separate crude oil into different fractions based on their difference in boiling points. Normally, the crude oil we took and it is heated to about 400 degrees Celsius to vaporize all the different parts of the mixture. Look at this diagram. The mixture of vapors passes into the fractionating column near the bottom. Each fraction is obtained by collecting hydrocarbon molecules which have a boiling point in a given range of temperature. For example, the fraction that we know, petrol, it contains molecules which have boiling point between 30 degrees Celsius and 110 degrees Celsius. The molecules in this fraction contain between 5 to 10 carbon atoms. These smaller molecules with lower boiling points condense higher up the tower. The bigger hydrocarbon molecules which have the higher boiling points condense in the lower half of the tower. The liquids condensing at different levels are collected on trays. This is a refining tower. In this refining tower, different products are obtained. Refinery gas, gasoline, kerosene or paraffin, diesel oil, lubricants, fuel oil, residue, that is bitumen. This is the basic refining concept. Here it mentioned number of carbon atoms present in that fraction, C1 to C4. Final product is refinery fuel gas, C5 to C8, gasoline, C8 to C12, gasoline jet fuel, C12 to C13, kerosene, used as a jet fuel, diesel, fuel oil, C30 to C50, diesel, C30 to C50 plus heavy gas oil, that also coming under gasoline, diesel and fuel oil. Refining, crude oil can be separated into different fractions by using the technique fractional distillation based on their boiling point. Lower boiling point fractions condense higher up the tower, and higher hydrocarbons boils at higher temperature and condenses at lower part of the tower. The liquid condensing at different levels are collected on trays. Now we will check about fuel. It is a substance which can be conveniently used as a source of energy. Any substance that we used as a source of energy in a convenient manner, that substance is said to be a fuel. Example, fossil fuel. A perfect fuel would be, it is cheap, it is available in large quantities, safe to store and transport, easy to ignite and burn, no pollution, capable of releasing large amount of energy. These are the conditions that we want to say one particular fuel is considered as a perfect fuel. Now we will check fossil fuel. Fossil fuel is derived from dead plants and animals which were fossilized over 200 million years ago during the Carboniferous era. Examples of fossil fuels: coal, natural gas and oil. Normally, efficiency of a fuel that refers to how much energy is released per unit amount. Based on that, you can say one particular fuel is efficient or not. First example of fossil fuel is coal. This coal was produced by the action of pressure and heat on dead wood. Different types of coal were formed as a result of different pressures being applied during the formation time. Based on the carbon content, the coal can be divided into mainly four: anthracite 90% carbon, bituminous coal 60% carbon, lignite 40% carbon, peat 20% carbon. Now we will check about combustion. It is a rapid chemical combination of a substance with oxygen involving the production of heat and light. When the fuel is a hydrocarbon, that hydrocarbon combines with oxygen, you will get two products, water and carbon dioxide, along with energy will be released. For example, propane. Propane undergoes combustion. We will get carbon dioxide and water, energy released. So simply you can say one general equation: fuel plus oxygen gives carbon dioxide, water and fuel plus oxygen gives carbon dioxide, water and energy. One example is given: natural gas that contain methane. Methane react with oxygen to form carbon dioxide, water and energy. This is the word equation. Simple equation is CH4 plus 2O2 gives CO2 plus 2H2O plus energy. See you again in our next session. In our next session, we will discuss about alternative sources of energy.